This audio lecture deals with metric measurement, kind of its importance and how it is used. The objectives for this lecture: to know the importance, to understand the common prefixes that are used in the metric system for length, mass, and volume, and be able to convert not only metric to metric, but also metric to the English system. So going from meters to feet, meters would be metric, feet would be the English system. A little bit of history about measurement, just looking at length alone. Throughout history, there have been lots of different types of measurements, and some are still used today. So if you work with horses at all, you might have heard that, particular breeds of horse are a certain number of hands high. Well, if you hold out your hand and compare that to anybody else's hand, odds are that there's going to be a slightly larger or smaller size in yours. So that is incredibly inaccurate, even though it's still used. Lengths and chains are the same way. You don't know exactly how big the length or how long the chain that the other person used to measure. Paces is similar. I know when I was a kid, we would make treasure maps for each other around the neighborhood, and it was really difficult to find the other person's treasure because even though they were very careful with their map, my paces would be different than the paces that my friends would take. Fingers as well, because they would be of a different size. So the metric system was really created, it was an international effort to standardize everything. And this is taken very, very seriously. Even today, there are vaults in Europe, is where they originated, where they keep the metric system. And these vaults are under lock and key. They have an armed guard standing out front to make sure nobody gets in there. Only authorized personnel that are part of the government's measurement and department are allowed in there. And when the U.S. wanted our own metric bars to put in our own special metric vault, we had to send delegations over there and arrange to get our own metric system copied directly off of theirs. It used to be that every several years they would then bring the metric systems together in one of the countries and recalibrate them all to make sure that they were the same, that the meter stick hadn't lost any atoms off the end, that the gram measurement was still exactly just 1 gram of measurement. However, since 9/11, they haven't been calibrated because it's become increasingly difficult to bring large metal bars on an airplane. So they haven't been calibrated for quite a few years, and some people in the Metrics and Measurements Office of the government are getting very concerned that perhaps our metric systems could be drifting apart over time. And that could become really important if you're looking at international trade. If you're using even a slightly different measurement than somebody else, but maybe you're selling them meters of cloth, and if your meter is slightly less than what they think their meter is, even if you measure very carefully, you're going to be inaccurate. If you send 2 million meters of cloth to the other country, well, that 2 million adding up little bit by little bit, your measurement's going to be very off from what they think they should receive, and that can cause tensions between different countries. So metric is very important, and it needs to be very accurate, which is why the metric system is only used in, or it's the only system used in science. A little bit about the metric system. It's very consistent. Length, the base is a meter. Mass, the base is a gram. When you're working with volume, you would start with liters. And temperature, we're very accustomed to Fahrenheit, but in metric it would be degrees Celsius. And we'll learn how to convert all of those between our system that we commonly use, the English system, and the metric system. First of all, we'll look at just the metric system by itself. The metric system, here's the base. Over here, we start with, our meter, gram, and liter at just 1 unit. And as we go larger, we just add a prefix, so deca, hecto, and kilo, to our meter, gram, or liter. And for each of those, we just slide the decimal point over 1. So 1, 10, 100, 1,000. And if we're going smaller, we start with the same base, our 1, meter, gram, liter. We just change the prefix, so deci, centi, milli would be the next ones down on the size. And again, we're moving our decimal. It was here at the end, and it skips over one place, so it puts it at the beginning of the one, and it skips again and again, so it moves the decimal in one position each time we change units. That's much easier to remember than if you're using our English system. So you guys do it all the time, I'm sure, so you know if you have feet, how many inches would be in a foot? Well, 12. So you'd have to, multiply or divide by 12 between inches and feet, and you probably know how many feet are in a yard, right? How many feet are in a yard? There are 3 feet in a yard, so again, you'd use that 3 to divide or multiply. How many yards are in a mile? See, it gets more complicated. You can't remember everything. You'd probably have to go and look that up. However, in the metric system, you would only move the decimal. You wouldn't have to remember all of those different intervals, like 12 and 3, and to make the conversions. So our metric system, again, all we do is move our decimal, depending on if we're moving higher or lower to a larger or smaller unit. And here's a little chart or graph. This is also available in your laboratory manual on page, I believe it's around page 25 or so in your lab manual, that you would have this exact same chart. And so if you're starting at anything on there, so maybe you start at your base of a meter, if you want to change that to a centimeter, going from our base here to centimeter, we're going down 1 jump, 2 jumps on our scale. So going down the scale, we move the decimal to the right. So if we were starting with our 1, and our decimal is here, going down the scale to go from meters to centimeters, moving the decimal to the right, we would go 1, 2 jumps, and just add zeros in there. If we were moving up, so maybe we started with micro down here at the bottom, and we want to go clear up to our base unit at the top. Now that's going to be 1, 2, 3, 4, 5, 6 jumps difference there. We still start with our 1, the decimal is here. Now we're moving up our scale, so we need to move to the left, so we'll go 1, 2, 3, 4, 5, 6 jumps over, that's where our decimal is, and then we just fill in with zeros. And that makes a lot of sense, because if you're looking at a meter, and a micrometer is going to be much smaller, so you're going to need very, very few meters to equal a micrometer. So we're going to get a tiny number in that direction. And here's a few other examples you can look through in that table as well. Other conversions that you'll need to make would be from the metric system, which we just covered, to our English system. So we could go kilometers to miles, or liters to gallons, or even centimeters to inches, or meters to feet. So all of those conversions, we just start with the metric. So maybe if we're doing kilometers over here, then we multiply, so multiply by this number that's between them. So we would take our number of kilometers, multiply by 0.06, and that would give us the equivalent number of miles. And we do the same for everything on the chart. Just multiply by the number that's down the middle, including for temperature to go from degrees Celsius to degrees Fahrenheit. Notice in the chart here, it gives you multiply by a fraction, then you add 32. That gives you the exact temperature conversion. It's okay in class, or for this class, to use the approximate conversion, which is also listed on the chart. So you multiply by 1.8 and add 32. It's pretty much the same thing, it's just already dividing out that fraction for you. And when you're filling out your worksheet, when you're using the approximate, just remember that they may not be perfectly exact. So some of the decimal places may be off by a little bit, but you can still assume that they're the same if that's the case. Going back the other direction, if you know, say, gallons or inches and feet and want to go to the metric system, make sure you're using the correct chart. Notice it's on a different page of your lab manual. So to go from inches to centimeters, we would then multiply by 2.5. Or to go from miles to kilometers, we would multiply by 1.6. So make sure that you're using the correct chart, either on page 26 or on page 27, depending on which way you're converting between metric and English. So go ahead and finish the worksheet. Please send me emails if you have any problems while you're doing this or questions, so I can help you solve those prior to returning to class on the 5th.